This is part 5 of the chapter Arithmetic Progression Standard 10th. We will be continuing the sums on finding the sum of the n terms. So this is the third sum. Find the sum of all the 2-digit multiples of 4. So it is specifically told us 2-digit multiples of 4. So which is the first 2-digit multiple? First 2-digit multiple of 4 is 12, and the last 2-digit multiple of 4 is 96. After 96 will come. So now we have to, when we want to find the sum, we should first know how many multiples are there. So we will find the number of multiples. So number of 2-digit multiples of 4, let it be n. So we have to find it by an is equal to n, a plus n minus 1. So 96 is equal to 12 plus n minus 1. I don't know n. So here a is the first multiple. The common difference is 4 because it's multiples of 4. So we have to just find this. So this is 96 is equal to 12 plus 4n minus 4. 96 is equal to 12 minus 4 is 8 plus 4n. 96 minus 8 is equal to 4n. 88 is equal to 4n. Therefore n is equal to 22. So there are 22 multiples. It means we have to find the sum of the 22 multiples. So therefore sum of 22 multiples, okay, it will be given as S22 is equal to, so we will use the shortcut method. There are 22 multiples, means n is equal to 22. The first multiple is 12 and the last multiple is 96. So this is 11 into 108, which is 1188. So we will say therefore the sum of 2-digit multiples of 4 is 1188. We'll go for the next sum. Find the sum of all the natural numbers between 250 and 1000. Now this is a big gap is given, which are exactly divisible by 3. So we will see the first multiple of 3 above 250. So when such sum comes, what we have to do is we have to divide 250 by 3. So it is 3 8s are 24, 3 3s are 9, 1. So what is 3 minus 1? The difference is 2. So this difference, if you add to 250, you will get 252. So 252 is the first multiple of 3 above 250. And what about the last multiple? So last multiple of 3 near 1000 is 999. Now we should know, so the number of multiples of 3 is given by the formula an means 999 is equal to a, which the first multiple is 252, n is what we don't know, and the difference here is always 3. So a is 252, D is 3 and AN is 999. So this is 999 is equal to 252 plus 3n minus 3. So this is 999 is equal to 252 means 249 plus 3n. Therefore 3n is equal to, it is 999 minus 249. So that is 3n is equal to 750. Therefore n is 250. So there are 250 multiples of 3. So now the sum of 250 multiples of 3, so that is S250 is equal to, we will again use the shortcut method. So there are 250 multiples. The first multiple was 252 and the last multiple is 999. So this is 125 into, this is 1251. So we will say the sum of all multiples of 3 required is 156 375. So it is 1,56,375. So this is how we do the sums. Now we can go for the next term. How many terms of the series 54, 51, 48 must be taken so that the sum is 513? So IP is given, sum is given, we have to find the number of terms which have to be taken. Now surprisingly there are two answers which we will be getting, because they have asked us to explain why we are getting the double answer. So we will write down this data. So the first term is 54 and D is 51 minus 54 means minus 3. N is, of course, we don't know, but Sn is given us to is 513. So we will just put it in the formula. Sn is equal to n minus 2, 2a plus n minus 1, because it is n minus 1 into D. So 513 is equal to n minus 2, 2 into 54 plus n minus 1 into minus 3, because D is minus 3. So when we cross multiply 513 and 2, we will get 1026 is 1026 is equal to, so this becomes n into 2 into 52 is 108 minus 3n minus 3n plus 3. So it is 1026 is equal to 111 minus 3n square. So we end up with a quadratic equation. Now we'll have to solve the quadratic equation. So it is 3n square, writing it in the standard form, plus 1026 is equal to 0. So I will divide it by 3, because dividing by 3, what do we get? We get as n square minus 37n plus 342 is equal to 0. So the options for it is minus 18 and minus 19. So we can write this as n square minus 18n minus 19n plus 342 is equal to 0. So it means n minus 18, n minus 19 is equal to 0. So n is equal to 18 or n is equal to 19. So this is what we meant by double answer. Now why are we getting the double answer? So we should find the reason. So if the 18th term, the sum of 18 terms is, the sum of 18 terms and 19 terms, both are same, it means the 19th term is 0, otherwise it is not possible at all. Is 519, therefore the 19th term is 0. So how do we know whether it is 0 or not? So what we will do is we will just put it in the formula. The 19th term is A19 54 plus 19 minus 1 into minus 3. So this is 54 plus minus 54 means 0. So that is the logic for the sums, both the things will be equal. So 18th and 19th term, S18 and S19 both are 513 because the 19th term is 0. We now go for the next type of sum. A sum of rupees 280 is to be used to award 4 prizes to children. Now if each prize after the first prize is rupees 20 less than the preceding prize, so if it is x, the price next will be x minus 20, next will be x minus 40, like that. We have to find the value of each price. So how do we start? So let the first price be x. This is the best way to start. Let the first price be rupees a. Okay, so now since there are 4 prizes, so 4 prizes means what will happen? S4 is equal to 280. So what is D here? Now here A, what is D? D is minus 20 because each succeeding price is rupees 20 less. Each succeeding price is rupees 20 less. So I have taken minus 20. So now we'll put in the value. So S4 is equal to 280 is equal to 4 prices upon 2. So this is 2a plus 4 prices are there, 4 minus 1, and each price is 20 less, minus 20. So we are getting 4 upon 2 means this is 280 upon 2 is equal to, this is 2a, now 3 into this minus 60. So this is 140 is equal to 2a minus 60. So 2a is equal to 140 plus 60. 2a is 200, therefore a is 100. So we got the first prize as 100. So if the first prize is 100, the second prize will be 80, the third prize will be, and the fourth prize will be 40. So this is the 4 prizes, are the 4 prizes. So this is how we do this sum. So if you total it up, we will get exactly 280. Now for the next sum, that is the 7th sum. A man repays a loan of rupees 3250 by paying rupees 20 in the first month, 20 in the first month, and then increases the payment by rupees 15 every month. So how long will it take to clear the loan? So this is just a AP sum. So let the loan amount be cleared in n months. Okay, now so what is A here? Rupees 20, because rupees 20 is the first thing, and D is rupees 15. So how do we do this? Now the total sum is rupees 3250. Now what we don't know is n, so we will just put in the sum of n terms formula, n upon 2. N is what we don't know, 2 into 20, because 20 is the first installment. Again n we don't know, n minus 1 into 15 is the difference. So cross multiply, so this becomes 6500 is equal to n into 40, 40, this is minus 15 plus 15n. So this is 6500. 6500 is equal to 25n plus 15n square. So this has become a quadratic equation. We'll put it in the standard form. 15n square plus 25n minus 6500 is equal to 0. Dividing it by 5 because the numbers are very big. Dividing by 5, what do we get? We get it as 3n square plus 5n minus 1300 is equal to 0. So we have to find the factors of 3 into minus 13 is minus 3900. So that is given by 65 into minus 60 by factorization method. So we will write this as 3n square minus 60n plus 65n minus 1300 is equal to 0. So we are getting 3n plus 65 and n minus 2 as the factors of this quadratic equation. So if we take 3n plus 65 is equal to 0, and we are getting minus 65 upon 3, it is rejected. You cannot have number of terms like this. So n minus 20 is equal to 0 means n is equal to 20. Therefore we can say he paid the loan in 20 months. In 20 months. So this is one. So next is find the sum of the 51 terms of an OP whose second and third terms are 14 and 18 respectively. So here the condition is different. So we will make this. So the second term is given to you as 14. The second term is nothing but 2 minus 1d. So I am having a plus d is equal to 14, which becomes my first equation. Then the third a3, the third term is given to you as 18. So this is 3 minus 1 into d. So this becomes a plus 2d is equal to 18. This is the second one. So when we start solving the first and the second equations, we get a and d both. Solving 1 and 2. So it is a plus 2d is equal to 18 and a plus d is equal to 14. We get d is equal to 4. So a plus 4 is equal to 14. Therefore a is equal to 10. So now we get a and d both. So we will put in the therefore the sum of 51 terms will be S51 is equal to n. So it is 51 upon 2 into 2 into a is 10 plus 51 minus 1 into d is 4. So this is 51 upon 2 into this is 20. So 51 minus 1 is 50 into 4 is 200. So it is 51 upon 2 into 220 means it is 5610. So we will say the required sum is 5610.